All right, here we go. Changing gears, folks. We're going to trig identities. Here we go. Yep, looks like we're going outside right now. Right now, we're going outside. Go right ahead. Okay.
That means we have to go outside, right?
Yeah, go ahead. I dare you. All right, folks, here we go. You've got to be able to transform these problems, and you're going to start doing that in pre-cal and calculus. Some of you, you got to be able to do these before those transformations in calculus, okay? Yes, ma'am. Okay. You must be able to transform problems before you get to the more difficult problems in calculus, yes. Here we go. All right, so major thing you have to know. That's the only thing I've written other than the title. Remember that no denominator can be equal to 0. Thanks. All right, never can have denominators equal to 0. Why? Then there's no solution. It's undefined, okay? So you cannot have anything. You cannot have your denominators equal to 0. We're going to be using the reciprocal identities. And we talked about this several weeks ago, and then we had to leave them for a little bit, and now we're back to them. But we're going to use the reciprocal identities. What are they? Folks, do you remember what cosecant of theta is equal to? What's that the reciprocal of? You'll know it as soon as I say it. 1 over sine. Okay? All right, so cosecant of theta is equal to 1 over sine theta, right? And then that means secant of theta is equal to what? Secant of theta is equal to 1 over cosine theta. Okay? So we're going to use these reciprocal identities. We're also going to use quotient identities. Pardon me? Funny that you should mention that. What is tangent theta? What divided by what? Sine divided by cosine. Good. Which also leads us to cotangent. Cotangent of theta, of course, is the reciprocal of what? Cotangent is the reciprocal of what? It's what, well, cotangent would be 1 over tangent. You're right. But isn't that also, if it's the reciprocal of tangent, and if tangent is sine over cosine, then won't cosine be cosine over sine? Ooh, it's an ugly looking S. cosine over sine. Now, folks, these things we don't put on our cards. The reciprocal identities and the quotient identities they're not card worthy. They're brain worthy, which makes them even better. So you cannot put them on your card. If you have them on your card, I'll take your card and I'll rip it up. And then you're going to really say ugly things about me in your head. I don't care. Y'all know that. But we're going to use these. So how are we going to use them? We're going to be translating sentences, translating equations. They're going to look one way, we've got to make them look another way. Okay? Two things we've got to be able to do. Does everybody have this? Everybody cool? Okay. Two things we've got to be able to do. First thing we got to be able to do is we have to simplify, or to simplify these trig identities. The first thing we have to do is we have to factor everything. So it's kind of like we're going to take the trig stuff and we're going to throw in that Algebra 2 review from the very first part of the trig class that you guys absolutely adored. No, you're not. No, you're not. Because it's like putting together a puzzle. I love this stuff. I don't know why. I'm kind of weird. But I love it. Second thing you got to be able to do is you have to remember that you must have common denominators. You must have common denominators. All right, you ready to see how this all plays out? So what we're going to do is we're going to have, you would be given instructions to simplify. And you might also be told to put everything in terms of sine and cosine. Those would be your instructions. You've got to put everything in terms of sine or cosine. So that means if you see a tangent, can you have a tangent in your answer? No. We got to change the way it looks. Okay? This is like giving these trig equations facelifts. They can only have sines and cosines. We have to make them nice and pretty and compact, and you'll see. All right, ready? Everybody ready? All right, here we go. First one. I want you to simplify cotangent theta, sine theta, secant theta. What mathematical operation is in between all three of those trig functions? Multiplication. So it's like having x times y times z, right? But we have to put it all in terms of sine and cosine. What can we change? What do you know that we can change? Cotangent. What can it change into? Cosine over sine. All right, write it. Cosine. Folks, if you want to put x's, put x's. Will we change the way sine looks? We actually will, just by doing one little simple thing. Put it over 1, good girl. Sine x over 1. Will we change the way secant looks? How will we make it look? 1 over cosine. What do you think we're going to do? Cross cancel. You're going to cross cancel. Here we go. Can I cross cancel cosine? Yeah, I can. Because it can cancel with this cosine down here, can it? Now this is where I have an advantage with my colors. I love my colors. What else can cross cancel? Sine can cross cancel. Say what? What's it equal to? What? What? What's 1 divided by 1? Really? You mean when I multiply cotangent times sine times secant, my answer is 1? For real? For real. That's it, right there. How about that? How about them apples? Question? You cool? Oh, okay. We'll figure it out. All right, cosine of t. Here we go. Cosine of t plus tangent t sine t. Okay? We've got to put these things in terms of sine and cosine. It's cosine t plus tangent t sine t. No. No, we'll be able to factor some. We can't factor anything out right now. Okay? But, folks, can I change the way cosine looks? Do I want to? No. All right, so it's going to stay cosine t. I could put it over 1, but let's see how this plays out for just a second. What about tangent? I want to change tangent to sine over cosine. Because remember, the instructions said to, what did they say? The instructions said to, put everything in terms of sine and cosine. What about sine? I got to leave it. But I am going to put it over 1. Why am I putting that over 1? Because I've got to multiply them together. All right, look what's going to happen. Now I'm going to leave it cosine over 1. What's sine times sine? Sine squared. Good. Sine squared t over cosine t. Now, folks, look at this, because you've got a fraction. First of all, let's look at your card. Get out your card. The cards. The cards. The Cubs. Do I have anything that is equal to, well, just have your card available. When you have two fractions, folks, what do you have to have? You have to have common denominators, right? So what's the common denominator going to be? I know Brady, but the girl. I don't know the girl. No, we can't do that because we're doing trig right now. We are. When I have 1 and I have cosine as my denominators, then folks, what's my denominator going to be? Cosine. All right, so watch this. Now this is where we have to go back to our Algebra 2 fun stuff. All right, here we go. I know that I have to have cosine as my denominator. Cosine is already my denominator in the second rational expression, so I'm not going to change the way it looks at all. I'm going to just rewrite sine squared t over cosine t. If I multiplied, what changed from the 1 to the cosine in the first fraction? I multiplied cosine to 1, right? If I multiply it to the bottom, what do I have to do to the top? I have to multiply it to the top. So that means I'm going to have the cosine times the original cosine that was already there. I'll put it in red because it's the original. And I know I'm showing every step, and some of y'all will not do this. What's cosine times cosine? Cosine squared over cosine plus sine squared over cosine. When you get the same denominator, we want to put this all over one denominator. So what is that numerator going to be? Cosine squared t plus sine squared t over cosine t. Now look at your card. Do we have an identity that is cosine squared plus sine squared? What is it? It's 1. Folks, this cosine squared plus sine squared, this right here, that's the Pythagorean identity. And it should already be on your card. And we're going to change that whole expression to 1 over cosine. And folks, what is 1 over cosine? Secant, which we just talked about a few minutes ago. I love this. I love it. But this is like rational equations, and that's why I like it. Just wait until you take calculus. If you're going to take calculus, you have to be able to do this. Okay? You still have to be able to. For me. Okay? Folks, I want you to look at this. Here's what I want you to do for tonight. Try complete page 242, 1 through 6. I'm going to tell you right now, if you don't do it at all, you'll never figure this stuff out. You have to attempt the work, okay? And I want you to start on it now while you're in here so I can help you, so you can help each other, okay? Everybody working on something.